So this one is for aldehydes and ketones chapter, of course, so which means that you need to know your aldehydes and ketones synthesis as well as the reactions on it. Okay, now whenever you have an organic synthesis, it's just called synthesis. Okay, well, what are you synthesizing? Are you synthesizing a functional group, or are you making another functional group on another functional group? This everything is called a synthesis. I've just labeled it reactions because just for showing you that it is a reaction of an aldehyde or a ketone. Okay, so that's the chapter we are on right now. So anyhow, let's look at this synthesis that we have here. And in this one, I can see that I'm going from benzene, okay, to a di-substituted benzene. So which means the benzene has to do reactions, two reactions, one here, one here. Okay, and so bromination, I know I can do that, no problem. But the bromination I need to make sure is at the meta position, okay, to whatever alkyl group I have. Now the alkyl groups that I have, alkyl, remember, is always going to give you ortho or para substitutions because it's an ortho-para director. So that's something I have to be aware of. So which means that there is something else going on here to give me a meta product. Okay, so what's going on here now? So if I look at this structure over here, at one glance, you might think, oh, is she missing an oxygen, but no, I'm not missing an oxygen. Let me write the benzene ring too. So you might think, oh, she's missing an oxygen. I'm not missing an oxygen. That oxygen I have converted into a carbon. Okay, I've substituted that with a carbon. And the only thing that can give me an alkene from a ketone or an aldehyde or a carbonyl is going to be a Wittig reaction. Okay, so which means that I need to do 3-4 reactions over here, right? So here is to get the ketone on the benzene ring, because this is where the keto position is. So which means that I need to do Friedel-Crafts acylation, right, to get the acyl group on it. Then the acyl group that I have, that's going to be a meta director, right? So then I need to do my bromination, and then the third thing I will have to do is the Wittig, okay, to get rid of the oxygen, okay, from there. So now I have my plan of synthesis, so I can go ahead and write out all the reagents. Now the way I'm talking right now, just so you don't really have to do retrosynthesis, but otherwise you could do retrosynthesis also with this. So whichever way you prefer. And by the way, when you do retrosynthesis, you just write the reagents on the arrows. That's it, okay, on the backward arrow. You never write arrow like this in organic chemistry. That's a major no-no. So we tend to write our reactions, like this if they're going backward, okay? So in any case, we don't have to do retrosynthesis here because it's a simple synthesis. So let me go ahead and get started. So the first thing we're going to do is Friedel-Crafts acylation, and the Friedel-Crafts acylation should give us this, right? So which means what do I need? 1, 2, 3 carbons, okay, that I need. So which means I will start with something like this. My chlorine should be over here, and of course I will need my catalyst. Otherwise this reaction is not happening. So once I have that Friedel-Crafts acylation, now I'm going to go ahead and do my bromination, which is with FeBr3. Try to be consistent in your catalysts, okay? So for Br2, you can try to use FeBr3 all the time, so that way you don't have to remember too many things, or you don't make a mistake. Don't use AlBr3, that's what I'm saying, okay? Just be consistent. Okay, so this gives us then our bromine over here. We still have the acyl group, so now all I need to do is convert my ketone to a carbon. And so the way I do that is by Wittig reagent, and my Wittig reagent of course is PH3P, that's the phosphine, and I need only one carbon, so that's CH2. And that's it, okay? I don't need to do anything more. That one carbon is going to substitute the oxygen, and that's it. It's small synthesis, okay? And half the time was gone in me talking, so you could have done the synthesis in less than 2 minutes.